Good morning, class. Okay, today I'm going to talk about the heat of displacement. Okay, so heat of displacement is when a more electropositive metals displace a less electropositive metal from a solution of its salt. Heat change will occur. Okay, and the heat of displacement is the heat change when 1 mole of a metal is displaced from its salt solution by a more electropositive metal. Okay, so before I talk about the heat of displacement, I will explain a little bit about the redox reaction. Okay, so class, redox reaction is actually a chemical reaction that is involving the oxidation and reduction occurring simultaneously. Okay, and there are types of a redox reaction. The first one is changing of iron 2 ions to iron 3 ions and vice versa. Displacements of metal from its salt solution. And then C, displacement of halogen from its halide solution. And then D is transfer of electron at a distance. So the one that is related to the heat of displacement is this one. Okay, displacement of a metal from its salt solution. So I will explain more about displacement of metal from its salt solution. Okay, so displacement of metals from its salt solution. Actually, class, the strength of a metal as a reducing agent can be compared by using electrochemical series. Okay, so actually redox is the process where the oxidation and reductions happen simultaneously. Okay, generally metals are good electron donors and therefore they are good reducing agent. Okay, however, different metal will have different strength as a reducing agent. Okay, so how do we know the strengths of that metal? Okay, so the strengths of metals as a reducing agent can be compared by using the electrochemical series. Okay, so what is electrochemical series, class? So I will talk about electrochemical series. So electrochemical series is actually the list of metals according to their ability to lose electron to form electropositive ion. Okay, later on I will show you the list of metal according to their ability to show the to lose electron to form positive ion. Okay, so I hope you can understand until here. Okay, and then okay, this one is electrochemical series. Okay, let us see from the top to the bottom. Okay, you see K. So K is potassium, Na is sodium, Ca is calcium, Mg magnesium, Al aluminium, zinc. We have iron. We also have lead, hydrogen, copper, mercury, silver, and gold. Okay, class. So for your information, at the tops of those metals, okay, is the most electropositive metals. Okay, and then at the bottom, Au, Ag, okay, so that is the least electropositive metal. So how do we know what is the reducing agent? Okay, so we need to always remember the electrochemical series so that we know which metals will be displaced from its salt solution. Okay? Okay, so in order to memorize this ECS, so ECS is electrochemical series. Okay, you can memorize it kalau Na is na, Ca is make it correct. Ca is cari, magnesium is makan. Okay, I'm sorry. A little bit. Okay, teacher, sorry. This one is cari. Okay, and then this one is makan. Okay, so kalau nak cari makan, ada zinger burger, french fries, snack plate pada cuti Ahad dan Ogos. Okay, so itu cara kamu untuk memorize the ECS. Kalau nak cari makan, ada zinger burger, french fries, snack plate pada cuti Ahad Ogos. Okay, so from here, you know which one is the most electropositive and which one is the least electropositive. Okay, so that you know K, potassium itu adalah the more electropositive. So that the strength of the metal as a reducing agent is increases. Okay, and then for aurium, for argentum and copper, they have the least electropositive. Okay. Okay, so heat of displacement. An experiment was carried out by putting an iron nail into copper sulfate CuSO4 solution. So figure 3.8 shows the result of the experiment. Okay, and then you see redox displacement of metal from its salt solution, like what I've explained to you before. Okay, so iron nail, copper to sulfate solution is the blue one. And then you see the other test tube where the nail become brown. So why has brown deposits form when on the iron nail? So why does the blue color solution become pale? Okay, what happened actually? Okay, so the brown deposit, which is copper, Cu shows that iron Fe has displaced copper from its salt solution. Okay, I repeat again. Heat of displacement is the change when 1 mole of a metal displaced from its salt solution by a more electropositive metal. So you see the following thermochemical equation represent the displacement reaction. Okay, you see when the ferrum is react with the copper sulfate, the product will be the iron sulfate or ferrum sulfate and copper as a metal. So you see here that iron displace the copper. Okay, iron displace copper. Okay, why? Okay, back to electrochemical series, you see where is ferrum and where is copper. Okay, so you see ferrum is the more electropositive, so it can displace copper from its salt solution and become a metal again, because copper is the less electropositive. Okay, so based on the thermochemical equation, 250 kg of heat is released when 1 mole of copper Cu displaced from copper to sulfate solution by iron ferrum. Okay, therefore the heat of displacement of copper from copper to sulfate solution by iron Fe is negative 250 kg mole negative 1. Okay, so this one is an example. Okay, you see step by step the solution. Okay, you read on the example first and then see the solution. So as usual, for step 1, we will do chemical equation, and then step 2, calculate the number of mole of iron where the Fe displaced from iron to sulfate solution. Okay, so the number of iron to sulfate, ferrum sulfate solution. Okay, so what is the number of mole? Okay, you can use MV. Okay, please remember, use MV per 1000. Okay, MV per 1000. Okay, to get the number of mole. So you'll get 0.0125 mole. So from the equation, 1 mole of iron is displaced from 1 mole of iron to sulfate solution. Okay, so therefore 0.0125 mole of iron Fe is displaced from 0.0125 moles of iron to sulfate Fe is ferrum sulfate solution. Okay, so step 3, you use MC theta to calculate the heat change. So mass of the solution 50 times 1 gram centimeter cube. So the heat change will be 0.84. Okay, and then step 4, calculate the heat change for 1 moles of iron where ferrum is displaced. Okay, so like usual, you need to uh, uh, get the heat change first, and then the heat change you divide by the number of mole, and then you will get the final answer. So step 5, write the heat of displacement. So don't ever forget the delta H, and don't forget to put the negative sign, 67.2 kg mole negative 1, because the negative sign shows that this is an exothermic reaction. Okay, so remember that heat of displacement is also exothermic reaction. Okay, class, I hope so far so good. If anything, you can ask me. Okay, so this one is the experiment to determine the heat of displacement. Okay, we'll go through this together later. Okay, we'll skip this for now. Okay, for example 4.10. In an experiment to determine the heat of displacement of iron by magnesium, okay, iron by magnesium, excess magnesium powder is added to 50 centimeter cube of 0.2 mole Dm-3 iron to sulfate solution. So the result of the experiment are shown below. Okay, you see initial temperature of iron to sulfate solution is 30.5, and then the highest temperature of the mixture is 40.0. So that is the change of the temperature. And then the questions already give you the specific heat capacity of solution 4.2, and then density of the solution 1 gram centimeter cube. Okay, and then the solution, calculate the number of moles. Step 1, as usual, please count the number of mole. Okay, but my advice is it's better for you to write down the chemical equation. Okay, if the question doesn't give you chemical equation, then you do chemical equation by yourself first. And then number of mole of ferrum to sulfate used by using mv per thousand, like usual, 0.2 mole decimeter cube times with 50 over 1000. So you will get 0.01 mole. Okay, you see here, dia ada tulis the chemical equation there. So magnesium solid, okay, plus ferrum sulfate, and then magnesium sulfate become a plus with ferrum. Okay, you see magnesium displace ferrum sulfate from its salt solution. Why? Because magnesium has the most electropositive, is the most electropositive metal compared to iron. So you go back to the electrochemical series to see which metal is the more electropositive and which metal is the least electropositive. So please memorize the electrochemical series. Okay, so from the equation, 1 mole of ferrum sulfate produce 1 mole of iron. Okay, so therefore 0.01 mole of ferrum sulfate produce 0.01 moles of iron. And then step 2, as usual, you calculate the heat change. So mass of the solution equal to volumes of solution times density. So first you get the mass of the solution. So mass of the solution is 50, and then the change of the temperature 40 minus with 30.5, you'll get 9.5 degree Celsius. So you count the heat change, mc theta, as usual, 50 times with 4.2 times with 9.5. Okay, so the final answer is 1995 joule. So you convert it into kJ. Okay, and after that, the last one is the heat of displacement. So you just divide it with 0.01. So you will get 199.5 kJ. So the heat of displacement of iron by magnesium, you must write the sentence. Class, don't forget to write down the heat of displacement of iron by magnesium. Delta H equal to negative 199.5 kJ mole negative 1.